So problem 23 is about Newton's law of cooling. So let's say we have an object here, and it has an initial temperature, and we're going to call it T naught for temperature initial. The outside air is an ambient temperature, A naught, for initial ambient temperature. Well, we have Newton's law of cooling that states that from the object's perspective, the temperature with respect to time changes at a rate proportional, so this is proportional, to the difference between the temperature of the object itself, so T prime of T is proportional to T of T minus the ambient temperature. So this would be minus the ambient temperature. Okay, now it's important to note here we're basically assuming that the ambient temperature stays the same throughout this whole process. We're not going to be raising the temperature of the world just by setting our nice cup of hot cocoa outside or something. So this tells us, or proportional to, tells us that T prime of T is equal to K T of T minus A naught. So this is equal to, well, that's as far as we can really go. But then they say, suppose that the ambient temperature is equal to 70 degrees Fahrenheit, and that our rate constant, so that's saying K, is equal to 0.05 inverse minutes. So that's like 1 over 20 minutes. So we're supposed to write this differential equation out, so we get 0.05 inverse minutes times T of T minus 70 degrees Fahrenheit. Okay, so that is essentially it. Yeah. Except that there is one last little thing with our equation here that we have. If we were like to draw a direction field for this equation, or a slope field, and that's our time axis and this is our temperature axis, we'd notice that as we have our equilibrium solution that I'm not going to compute, but as t gets really, really large, our slope becomes positive. So this is actually the way that we've written this. It's a divergent equation. Like as t goes off to infinity, it would diverge. Well, that's not what we want, because our temperature should converge to a certain value. So if we actually negate this equation and put a minus sign in front of it, then our nice direction field would change. It would become, here's our equilibrium solution, but as t gets very positive, this negative sign would make it actually become the overall derivative very negative, and vice versa for below. So that means that we now have a convergent equation as t goes to infinity. So yeah, so that's basically it as far as problem 1.1.23 goes. Check back on my channel for more worked examples. Thanks.